previous lesson, we saw where the formula for the first derivative comes from. Remember that the first derivative represents a formula for the gradient of a tangent. So this is not a way to find the equation of a tangent, just a way to find the gradient of a tangent. In this video, we are going to learn how to find the derivative from first principles. From first principles mean we are going to use this format. We're going to limit h towards 0. In the previous lesson, we learned that h represents the distance between 2 points, and we are gradually making that distance smaller or tending to 0. We also learned that we cannot substitute 0 directly into the expression because we are not allowed to divide by 0 in the derivative. Here's our first example. Let us find the derivative of fx from first principles. Remember, the derivative represents the gradient. So even before we calculate, we can see that this is a linear expression. If you remember linear expressions, it's y equals to mx plus c. And then the gradient would be 3. So therefore our first derivative will also be 3. But we want to practice how to find it from first principles. So let us first establish fx plus h. What it means in the position of x, I substitute it with x plus h. My next step is to multiply out. That's 3 times x and then 3 times h to get 3x plus 3h plus 9. Now that I have fx plus h, I can use the first principle expression. It is good practice to first write down the formula and then from there do your substitutions. So for every question where we are asking you to find it from first principles, I recommend that you write down the formula first. Now this is important. I keep the limit. I don't get rid of the limit just because I am substituting. The limit is what we get rid of last. And I cannot get rid of the limit now because I would substitute h with 0. And in this expression, that will be undefined. So in the place of fx plus h, I have 3x plus 3h plus 9. Then I need to subtract the full fx. And that's why I write it in brackets. So if you do the subtraction, it's better to write it in brackets. Otherwise, you'll just have negative 3x plus 9. But in actual fact, it's negative 3x minus 9. Now if I simplify, 3x minus 3x would be 0, plus 9 minus 9 would be 0 as well. So I'm left with 3h over h. The h's will cancel out, so I'm left with 3. And now I can get rid of the limit because there are no h's. So the first derivative of this equation is 3. And as I also explained earlier, the first derivative represents the gradient, and the gradient of this linear expression is 3. Now, let us move on to a quadratic equation. So I have fx is equal to negative x squared plus 7x minus 16. Our first step is to establish fx plus h. So in the place of x in the original equation, I substitute it with x plus h. So it's negative x plus h squared plus 7x plus h minus 16. And now you need to be careful when you multiply out. So it is negative, and then I need to expand the square brackets. So it's x squared plus 2xh plus h squared. Remember, it's not just x squared plus h squared. You need to multiply out completely. Then 7x plus h is 7x plus 7h. And then minus 16. Before I substitute into the formula, let's get rid of all the brackets. So it is negative x squared minus 2xh minus h squared plus 7x plus 7h minus 16. Now this can look quite daunting because there's no way to simplify this. All of these terms are unlike terms. That is okay, it will simplify once we substitute. So before I simplify, I first write down the formula I'm going to use for first principles. And you would find this on your formula sheet in the final exam. In the place of fx plus h, I have the full expression which I found earlier. So that is the full expression of fx plus h. Be careful when you rewrite it that you don't miss signs, and also work thoroughly before you substitute. Then I'm subtracting fx plus h, and I put that in brackets. So fx plus h was negative x squared plus 7x plus 16. Now we can simplify. Negative x squared plus x squared would be 0. Negative 2xh, there's no other xh's, so I just bring that down. And I bring down negative h squared because there are no like terms. Plus 7x minus 7x becomes 0, so it falls away. I bring 7h down, and negative 16 plus 16 would become 0. So if I simplify the numerator, I'm only left with 3 terms. Now I cannot substitute h with 0 yet because this will become an undefined fraction. What I do see is that all of these terms have an h in. So I take out h as a common factor, and I'm left with negative 2x minus h plus 7. The h's now will cancel out. So I'm left with a limit of h towards 0 and negative 2x, negative h plus 7. Now it is valid to substitute the h with the 0, and that will become 0. So it's negative 2x plus 7. And this is the first derivative of the quadratic equation. And this negative 2x plus 7 represents the formula for the gradient of the tangent to the curve at any point of x.